Okay, so we have a nice little setup here with a battery, an ammeter, and a set of parallel plates. This is a nice little capacitor. Well, when you set it up like this, these are metal plates here and hooked to there. So what happens is you get the little charges, the little electrons roll over to the negative side. What was found out not too long ago, and it was pretty interesting, is that if you took some light, somebody took like like a red light here, and you shine it on the plates, sometimes things would happen. So if I shine red light on it, well, nothing happened. If I put it over here, if I shine some green light on it, let's have some. Here's a nice little green, some green light. Nothing happens. It's kind of interesting. So then, but if the wavelength got short enough, the light would come in and it would knock one of these electrons off. So it would come in, it would get absorbed somehow. This would get popped across and then zing back around. All right, to then come around. So then I would read a current over here. So at the time they said, oh, look, this is a higher energy wave. If I made my red more energy, then it should knock some off. So let's just let it shine on there for a really long time. So we'll shoot, just let it sit there for a while, and the light's shining on it, and nothing happened. It was kind of strange. So let's increase the intensity. Let's increase the power over the area. So with a wave, the energy is stored in the amplitude. So let's make a higher energy wave. So let's get this out of the wave, and now let's run a real high energy wave, and nothing happens. So let's try it with a different frequency band. So we'll try the green one for a while. We'll let it sit on there for a long time. Nothing happens. Ooh, let's jack up the intensity a little bit. Ooh, here we go. High intensity. Nothing. All right. So now, what if I send in this wave again? Well, it pops one off. Get a little bit of current. This comes in. The current comes around. All right. And then it comes back. And then, well, what if I have a higher intensity wave on that one? Well, if that has I forgot to cut one out. So if I had a nice high intensity one, that one would knock, say, 2 off. All right. So the wave energy didn't, because the wave theory just didn't describe this very well. It because this little thing had the same amount of energy as this, and it didn't knock off any electrons. This one didn't knock on any. The red didn't knock off any electrons, but the blue one did. And so it took Al Einstein to come up with this, and he said, well, light doesn't act like this. It acts like this. It comes in little chunks. So no matter how many pokes, how many little chunks of light you send in, there's not enough energy in one of these chunks to knock this electron off. However, there is enough to knock this one off. So the total energy is the same, but the energy per poke, or in this case, photon, is high enough to knock that off and get to zing across to the other side. So the energy here, the energy in that photon, so there's your energy. We know that from looking at Planck's constant. So the energy that's in that photon is HF. And the minimum energy then to knock an electron off, so that energy, I'm trying to knock it off and zing it around, but I have to be able to remove it from the plate. So that's the amount of work that's required, work to remove the electron from the plate, from the metal surface. We're going to give that a symbol. We're going to call that phi, and we're going to call that the work function. So then the energy required, the energy of the photon is going to remove the electron from the metal surface. So that's HF equals phi. Now, what happens if I bring a larger photon in on this on some sort of like, oh gee, what do I got here? I got a, I have a deep purple one. I'll make it pink just because now I need it. I got to make sure it's right. We'll make it real high energy. Where's my little, here we go. All right, here we go, like an X-ray or something. So when this comes in, holy smokes, bing, that's going to zing across. It's not only going to remove it, there's going to have some extra energy, and that's going to go into the kinetic energy of the electron. It's going to zing across there faster. This is what's known as the photoelectric effect. Wave theory doesn't do very well with this because it just doesn't have, you have to actually poke it off, not just kind of slowly lift it off. So the photoelectric effect, the energy in the photon, let's zoom in here. The energy in the photon removes the electron from the surface and then gives it some extra energy. The work function for different metals is different, and that's something that we'll give you as we move along.